We are going to learn where the quadratic formula came from. We will start by looking at a standard form quadratic equation. We want to try and determine what is the value for x. We will start by subtracting c from both sides so that you have ax squared plus bx equals negative c. Now we need to get x by itself, so divide everything by a. Now we will color code each term. Each of these terms represents an area for a specific shape. We will use this blue square with side length x to represent x squared. This is because since a square has sides of equal length, its area is just the side length squared. And if our square has side length of x, then its area will be x squared. We will use a green rectangle to represent the term b over a times x. The area of the rectangle is length times width, and with a length of x and a width of b over a, the rectangle will have an area of b over a times x. We will use a red rectangle to represent the area for negative c over a. We do not need to know the side lengths, just that the red square is equal to the area of negative c over a. So we are looking for the areas of the blue square and the green rectangle to add together and equal to the area of the red rectangle. The first thing we do is to add the two shapes together. The blue square and the green rectangle share a common side. This is the side length of x. We want to try and keep the overall shape of a square. So instead of just adding the green rectangle to the blue square and making one long rectangle, we will instead split the green rectangle into two and add the two halves to either side of the blue square. When we split the green rectangle into two, we are left with two smaller rectangles, both of length x, and a width of 1/2 times b over a, which is the same as b over 2a. After adding these shapes together, we have almost the shape of a square, but we are missing a small bit of area to actually complete the square. We can add a small square into this spot and complete our square. Because both widths of these rectangles are b over 2a, then our square will share these lengths as its sides. And when these sides are multiplied together, we see that the little square has an area of b squared over 4a squared. We just added something to one side of our equation, so now our equation is unbalanced. To fix this, we will add a shape with the same area as the little square to the other side of the equation. Before we continue with the shapes, we will make sure that our algebraic equation is following along as well. Since we added the area of the little square to both sides of the equations for our shapes, we will also do the same for our algebraic equation. We will add b squared over 4a squared to both sides of the equation. Since we added the red rectangle and the yellow rectangle together down below, we will also do the same to their algebraic partners. We first need to have the same denominator, which is 4a squared, and then we add them. We end up with b squared minus 4ac over 4a squared. So this also becomes the area for our rectangle down below. On the left side, we have a square with side length of x plus b over 2a. And since it's a square, that means that its area is x plus b over 2a squared. We want this to equal the area of the rectangle on the right, which has an area of b squared minus 4ac over 4a squared. Since we are looking for the value of x, we see that x is only found on one side of the equation. Because that side is being squared, we will take the square root of it. What we do to one side, we must also do to the other side. Thus we will end up with x plus b over 2a is equal to the square root of b squared minus 4ac over 4a squared. When either a positive number or a negative version of that same number gets squared, the product will be the same. So when you take a square root, you have to account for the fact that the square root could either be positive or negative, so we will write a plus or a minus out front. We will now simplify this equation. A radical can be split among a fraction. So we now have plus or minus the square root of b squared minus 4ac over the square root of 4a squared. Since the square root of 4 is 2 and the square root of a squared is a, then the square root of 4a squared is equal to 2a. We will get x by itself by subtracting b over 2a from both sides, and because everything on the right side is over 2a, we are left with x being equal to negative b plus or minus the square root of b squared minus 4ac, and all of that over 2a. This is the quadratic formula, and this is how you prove it.